In this video, we'd like to continue our tour through Python functions. We've already looked at callbacks and lambdas, and in these next two videos, we're going to look at filtering and mapping. And so these are two different techniques that we can use to evaluate data and to make decisions about data. Here is this function called filter in Python, and what filter does is that it applies some criteria to the elements in an iterable, like a list or a dictionary, and it extracts the elements that fit those criteria, and it ignores elements that don't fit those criteria. So this criteria list is really just a function that we'll write, and that function returns just either true or false. So it's a Boolean function in that regard. It doesn't really do anything else. It doesn't have any other responsibilities or obligations. And obviously when it's true, filter will copy the particular element into a new data structure, but if it's false, then filter will ignore that element and just go on to the next one. So let's look at how this might work with a little bit of an animation that I put together here. So let's say that I have this list. It only has 4 words in it, but what I would like to do is to capture the words that are longer than 4 characters long. And the ones that are shorter, I just want to ignore. Now the little green bar down here at the bottom is this new data structure, and so the filter function is going to copy words into that little green bar down there if they fit the criteria. So the first thing that filter does is it applies my criteria. Here is the length of the word greater than 4, and it applies it to that 0th element. Well, Rob's isn't longer than 4, so that is false, and so therefore nothing happens. And then it moves that criterion to the next word. It applies that function to the next word. And Bog is not longer than 4 characters either, so that one is false as well. And we just continue down the list. So filter applies len is 4 to the word clocked, but now it's true. So we copy clocked into this new data structure, this green bar down here at the bottom, and we go to the next word. Malpractice is definitely longer than 4 letters, and so therefore we copy malpractice into this new data structure as well. So there are a couple of interesting ideas here that we haven't really seen before. Number one is that my original list doesn't really move. Now in the past, what we would have done is we would have iterated that list and we would have sent the list to the function. So in that sense, len is kind of static or a rock, right? It's like, sometimes I joke that it's carved in stone in some ways. And what we do is we send bits of data to a stable, static function. But that isn't really the case here. It's reversed. Now, my original list is the thing that doesn't move. It is not portable, but instead, the function moves. So the function visits each element in turn and makes a decision about that element, true or false. And then what happens at the end is that those elements get copied into a new data structure. Now, you might think that because we started with a list, that we'll end with a list, but we actually don't. We get what's called a filter object, which is a new kind of object in Python that we haven't really seen before. We've looked at objects a lot, but this is one that we haven't seen yet. We'll talk about it a little bit more as we go forward here. Why would you want to do this? It just seems kind of weird maybe, especially with only 4 elements in a list. But the filtering operations that we're doing here, as well as the mapping operations, which we're going to see in the next video, are ways that we work with big data. And big data is a big deal, right? And so what happens if we get too much data is that our data looks like a mountain, and the little tools that we're using are so much smaller. So instead of taking megabytes or terabytes or petabytes or anything and sending it to a little tiny function, one of the things we do in a big data style of analysis is that we just bring the tools to the mountain. And the other cool thing about this is that in big data operations, we can multiply the tools. And so we could have 100 little miners with tools going to the mountain. We could have 100 or 1,000 different computers all working on the same mountain because we've simply copied the tools to them. So even though we're not going to really talk about big data in this class, and we're not going to have a list of criteria like what is really actually counts as big data, this is a technique that you will see a lot because it is used really, really commonly in big data applications. So to do the filtering properly, we really need two things then. We need that list or dictionary that is all of the data, that is the mountain of data that we want to look at. And then we have another function, and that function is going to get applied to each element in that list or that dictionary. And it is the job of the filtering function to do that. So we don't have to tell filter how to apply that function to everything. It knows how to do that automatically, which saves us a little bit of work, right? Now, that function is really just a Boolean. So no matter how big that function is, it could be one line, it could be a lambda, it could be 100 lines long, it could be 1,000 lines long. At the end of that process, all it has to do is return either true or false. So I could write some really, really, really complicated criteria, and as I apply it to every element in a list, right, those complicated criteria just make a decision. True, does it adhere to the criteria that I've listed, or false, does it not? That's all we need to do. Now, this len is greater than 4. We could write this really easily as a traditional function, right? It might look like this in Python. So I just send a word to longer than 4, and if the length is greater than 4, then I return true, else I return false. And if I have my function defined with def called longer than 4, I can just send that as the first parameter, or the first argument, to the filter function. But we can do these things as lambdas too. So let's take a look at that function, and let's actually boil it down a little bit and turn it into a simpler lambda function. Now what's interesting is that len of word is greater than 4 is just a Boolean expression. It sits there in the if statement, and what that means is that Python will evaluate that thing as either being true or false. There aren't any middle grounds in Boolean stuff in Python, right? So my code here is actually a bit redundant, because what my code says is, hey, if this expression is true, then return true. If this expression is false, then return false. So I could shorten that, I could simplify it, and I could just say, hey, return this expression, because it's going to come out to be either true or false anyway. And so I could do this. Just return the expression, the length of word is greater than 4, because that expression will either be true or it will be false. And so if I take that longer one, that is a long if-else statement, I can actually boil it down, and I can say, well, longer than 4 really only needs to return the len of word greater than 4, because that's an expression that will simplify into a Boolean true or false. And that means we can write it as a lambda. And we already know how to do that, right? We take out the def, we take out the name, we take out the return. And so what we have is a little lambda function. It accepts as input an input parameter called word, and it just returns the Boolean value true or false of whether the length of that word is greater than 4. And so when I send that to filter, it looks just like this, right? Just sending that little tiny lambda function, and that little tiny lambda function will get applied to each element of the list in turn. Now, what I find really fascinating about filter is that by itself, it really has no behavior of its own. It's kind of hollow and empty and meaningless. And we talked earlier when we were discussing callback functions that what a callback function does is it modifies the behavior of a different function. This is a great example of that because by itself, filter doesn't really do much. It doesn't have any identity unless we send it a callback function. Now, footnote, true. If you don't send a function to filter, what it will do is it will look at every element and ask if that element is truthy in some kind of Python way, right? So none and false and maybe 0 are kind of false-ish kinds of things, but that's not very interesting. So what's fascinating here now about filter, right, is that we do have to send it some behavior, otherwise it just doesn't have anything by itself, right? Now, again, what we get back is not a list. It would make sense if that were true, but it's not what we get. It's not what Python chose to give us. So Python gives us a filter object. Now, a filter object is iterable, so we can put it in a loop, and we can actually check to see. So, like for word in my filter object, print the word. I can do that. But if I wanted to find out some other information, like how many words fit this criteria, then I will need to cast my filter object to something else. Len doesn't work on filter objects, but it does work, for example, on lists. So if I converted my filter object into a list, then I can ask Python to tell me how many words are in there or how long it is. So let's look at that a little more closely here, right? So here's my 4 words. I'm sending my lambda function to the filter object, to the filter function, which is looking through words. And what I get back here is that filter object. And now I can iterate that filter object, which is totally fine. No problem at all. But if I wanted to do something else, like just to ask Python how many words are in that list, then I have to cast the filter object to a list. And so you can see my embedded functions here, right? So we can kind of start in the middle. I've got a lambda function, I'm applying it to words. Filter is the thing that's doing that, but that gives me back a filter object. So I send the filter object to the list constructor, and then I get back a list, right? So we'll play with this on the terminal window here in just a minute. One last thing before we get there, though. What we're doing is building up a list here, or a set of things that are iterable. And in Python terms, something that's iterable is just an object that we can place into a for loop. And we've got several of these things now that we've seen, right? Strings and lists and dictionaries are all iterable. We've seen that we have a file object that's iterable as well. We use that with comprehensions when we're loading things. And now we have a filter object that is also an iterable object. And you can see in the grayed out version here, we will see one in the next video as well. Okay, here in the interactive shell, I just got started typing in my with block here. So I'm going to load lexicon.txt into a giant list called lex, and we'll just see how many things we have got in lex. 110,000, perfect. That's exactly what we wanted. Now, I don't want to work with 110,000 words. So what I'm going to do is I'm going to import the random module first, and I'm going to say words equals a random sample, which I can't spell, from lexicon. Unless we get, I don't know, 20 words or so. There we got 20 nice words that we can play with. And so I'll filter this smaller list so that we don't have to look at 110,000 possibilities. So I think maybe one of the first things that I'll do is I just want to see which words have R's in them. Let's just do it this way. I'm going to call this an R object. And so what I'm going to do is I'm going to filter the words, but I need to send it a lambda function. I'm just going to put a little space in here. Let's say that we accept input into a word variable called W. That's local to the lambda function. And all I want to know is whether R is in W or not. That's my little tiny lambda function. That's a Boolean expression. R in W, true or false. And I want to apply that to words. So what my R object is now, you can see, is a filter object. Now, we said that filter doesn't produce something that I can do the length of. So if I try to get the length of my R object, you'll see that an object of type filter has no len, so I can't get there. Now, if you think back to objects, and we've talked about objects a fair bit, you realize or remember that we can do a directory and we can look inside the object. So if I look inside of our object to see what's there, you'll notice that I get tons of these kind of double underscore functions, right? We kind of call these dunders, double underscores. They're kind of magic methods or magic functions. And that's all that's in here. There aren't anything else. There's no variables in here. There are no other methods I can call. It's really empty and hollow. You will notice, though, that it is an iterable because it has a magic method called next, and that's the magic thing that makes iterables be iterables. But if I wanted to find out how many items there are in there, I have to cast my R object into a list. So I just send the R object to the list constructor and I get a list back. And now if I ask it how many there are, there happen to be 11 in there. And it can actually just ask in the interactive shell, just what is our list. So here are all the words that begin with R. But I can do this, right? For word in our object, print word. Oh, I used it up. This is a really good thing to know. This is a really good thing to know about iterables, and it's something that I haven't mentioned before in the past, but we just encountered it right now, which is very helpful. When I converted this into a list, what happened is we iterated through the R object using the next method. And what happened is that it's like a cassette tape in some sense. We started at the beginning of our object and we went all the way to the end of our object. And so in order to look at our object again, we kind of have to rewind the tape, as it were. Now, with files and some other iterables, I can, in fact, rewind the tape and start over. But I can't with one of these. So the only way that I can get that back is to recreate our object, which I can do if we go to here. All right, so now let me do it again. I'm just going to use the up arrow here. Where am I? Yeah, there you go. For word in our object, print word, and now I can see all of the words. So a little, maybe this is a technical lesson, but occasionally you'll get one of these iterables that you cannot reset to the beginning. You can't rewind the tape, as it were. And so a filter object is one of those. A file object I can rewind, but this one I can't. Okay, well, if you'd like to play with some filtering on your own, here are some ideas for you to work with. Again, take lexicon.txt, which is up on eClass, and you can work with the whole list. If you want to boil that down, just take a sample, you can do that too. But working with the whole list, here's one that's really interesting, is just to extract all of the words from lexicon.txt that are exactly 22 letters long. There are a bunch of them, and so you can find those out writing a little lambda filter function. Or just extract all the words that start with an X and also end with a Y. And there are a couple of string methods that you can use in order to do that. Here's one that's a little bit trickier, but it's exactly doing the casting to a list in exactly the way that we just did. See if you can write in one Python line how many words in that lexicon.txt file end with IES. So again, load that into a variable and then write a little lambda function that gives you a filter object that converts it to a list and that sends it to len. So you're nesting a whole bunch of functions there in that one to get an answer. Here's one that's a little bit harder, but it is very doable as a little lambda function that you can send to filter. Look through lexicon.txt after you've loaded it up to extract words that have a counterpart that starts with A. So for example, moral is a word that's in the lexicon, but the word that has an A in front of it, amoral, is also in the lexicon. Void is in the lexicon, but so is avoid. Board is in the lexicon, but so is aboard. So it seems complicated, but it's quite possible to write a very tiny lambda function that allows you to do that. Now, here's a hint that it might be useful to go back. We did a speed test about what's faster, a list or a dictionary. We kind of did that in class as a code-along exercise. The short answer is that a dictionary is faster. So you might want to try this by loading lexicon into a dictionary and using the dictionary in your filter function. All right. If you can't get that as a lambda, you can also write that longer as a def. But here's two examples that you could write as a def. So write a little def function that counts the number of vowels that are in the word, and use that function, that named function, to filter out all of the words that contain exactly 10 vowels. There are a bunch of those as well, right? And then here's one that we're going to return to a little bit later. See if you can write a def function that returns true or false whether a word does or does not contain all 5 vowels, A, E, I, O, U. Now, they don't necessarily need to be in that order. That's fine. Just does it contain an A or an E, an I, in any order whatsoever. And then see if you can filter out all of those words from lexicon. Now, we're going to return to that exercise later when we learn string pattern matching templates called regular expressions. And one of the things we're going to do is look for all of the words in lexicon that do in fact contain the letters A, E, I, O, U in exactly that order. But we're going to use the regular expressions to do that a little later. All right, thanks. Well, that's all we're doing today for filtering functions. So good luck practicing that. And we'll move on to something similar, which is mapping functions.